The new Pasco sonometer is music to the ears of teachers that want their students to explore the science of sound. The new Pasco sonometer allows students to easily experiment with the length and tension of guitar strings. The sonometer is designed to hold 2 strings with different linear mass densities. After attaching the ends of the soundboard, attach 2 of the 8 supplied guitar strings. There are 2 different sizes to choose from. It's recommended that the teacher perform these steps. The initial setup is described and illustrated in detail by the instruction manual. Tension can be varied by hanging up to 3 kilograms of mass on the tensioning lever. The pivot increases the force by a factor of 5, allowing for a maximum string tension of 147 newtons. After hanging the desired mass, the tuning pegs need to be adjusted so that the tensioning lever is horizontal for an accurate tension value. The built-in bubble level makes this step quick and easy. The length of the vibrating part of the string can be adjusted by moving the bridge. The indicator on the bridge shows the length on the built-in ruler, allowing for an accurate length measurement. There are 2 methods for measuring the frequency of the sound produced by the strings. Let's take a look at how each one can be used in an example investigation. One application for the sonometer is to investigate the relationships between frequency, wavelength, period, and wave speed. Students can find the wavelength of the measured frequency because the string is fixed at both ends. The string length is half of a wavelength, so the wavelength is twice the string length. After taking measurements, students discover the relationship between frequency and wavelength using the graphical analysis tools of SparkView or Pasco Capstone software. One approach is to vary the string length while keeping the tension constant and measure the frequency with a sound sensor. So I have a sound sensor here suspended over this string, and I have Pasco Capstone set up with a FFT display. So if I start monitoring it, we'll see all the noise from me talking, but once I pluck it, we will see just the sound of the string. And then I stop monitoring it, and then I can easily measure the frequency of the fundamental there. And so that's 423. After taking 5 to 6 measurements, they can quickly create a graph of wavelength versus frequency. Further analysis reveals that a graph of wavelength versus 1 over the frequency, or period, is linear with a slope equal to the speed of the transverse wave on the string. Alternatively, they can strike a tuning fork and adjust the length of the string until it resonates. Using a paper rider makes this resonance more visible to students. So a paper rider is just a little piece of paper bent in a V shape. I like to put a few on there so we can more likely see it with the camera. And put it on the sounding board. They shake, and they'll shake the most when I adjust the length so that they're matched. Oh, right there. Sometimes they pop off. That's what I was hoping for. Let's try one more time. There we go. Students could alternate plucking the string and striking the tuning fork until the pitches match. This can be difficult for some students, especially in a noisy classroom. After matching the frequencies of 5 to 6 tuning forks, students perform a similar analysis as students using a sound sensor. Teachers can assign different strings to adjacent groups so that they have different wave speeds. Some groups could use sound sensors while others use tuning forks. After analyzing their strings, students can make predictions about the frequency of string lengths or tuning forks they didn't measure and then test them with a sonometer. They can even use their analysis to predict the behavior of other waves like sound, light, tsunami, and earthquake waves. You'll find detailed lab instructions and a teacher guide for this lab and more in the Pasco Experiment Library. Look for more sonometer videos on the Pasco Sonometer webpage or our YouTube channel. Thanks for watching and listening.